What happens at that postsynaptic membrane is pretty interesting. Information, that is, those postsynaptic potentials, are processed right there. The postsynaptic potential is a graded potential in the postsynaptic membrane in response to the neurotransmitter that crosses that synaptic cleft. And there's two types, and I want you to think about those words for those two types: excitatory postsynaptic potential and inhibitory postsynaptic potential. So one of these is a go signal and one of these is a stop signal, and I'm sure you can figure out which is which. The excitatory postsynaptic potential, EPSP, is a graded depolarization, and it shifts the membrane closer to the potential, or to the threshold. This means that the membrane is facilitated, and the more facilitated it is, the more likely it is to trigger an action potential. On the other hand, the inhibitory postsynaptic potential, IPSP, is a graded hyperpolarization. So it shifts the membrane away from the threshold. The membrane is inhibited. So you would need greater than a normal stimulus to trigger the action potential. Summation is the integration of the effects of the multiple graded potentials. So there are a combination of EPSPs and IPSPs. For example, the arrival of two different neurotransmitters at the same time opens two different sets of ion channels. The net effect, in the case shown here, may be no change in the membrane potential. This makes a little more sense when you look at the axon itself, or the cell body. You can see all these thousands of axon terminals coming in and synapsing with the cell body and the dendrites. All of these are they are either excitatory or inhibitory, and when and these neurotransmitters that released are either excitatory or inhibitory. So the axon hillock integrates everything, and it determines the rate of the action potential generation at that initial segment. So it integrates all this information coming in from possibly thousands of different neurons. There are two types of summation. The individual EPSP or IPSP has a small effect on the membrane potential. A single EPSP will not cause an action potential, but they can combine through summation. And there are two types of summation: temporal, meaning time summation, and spatial, meaning space summation. Temporal summation is when a single synapse is stimulated repeatedly. With maximum stimulation, the action potential can reach synapse every millisecond. And this would cause the release. Each action potential is going to cause the release of more and more acetylcholine into the synaptic cleft, and therefore more depolarization is going to occur, and possibly threshold will be released. With spatial summation, you have multiple synapses arriving at the same time. Multiple action potentials arriving at the same time. So each synapse will be active. And so the degree of depolarization depends on the number of active excitatory synapses and their distance from the initial segment. The action potential is greater if membrane reaches threshold. Which of these describes spatial summation? Action potentials arrive at the target cell from more than one synapse.